Okay, so provisioning in IPv6 networks. So I have started looking into that. Got um, quite a lot of things actually done. We supported IPv6 in Foreman for a while already, so there was basic support for it all over the place, but I wanted to connect all the dots and actually make the provisioning possible in Foreman and IPv6 environments. Currently, I was focused mainly on pure IPv6 networks, so dual stack networks support probably exists, but I didn't test it, so that's up to you guys. Um, so how provisioning looks in Foreman? So you have basically you have two big pillars in provisioning. You have the image-based provisioning and you have the network-based provisioning. You can either use this or that. So in image-based provisioning, again, it depends on your systems. You can either provision by cloud init scripts or SSH post provisioning. We support both of those. In this pillar, basically IPv6 is not really playing any role. It's just a matter of configuration being placed in the right places. That's all. So image-based provisioning is quite the standard. The network-based provisioning is a bit more tricky, and I'll talk mostly about this one. So how network-based provisioning actually works. You have three players in this area. You have the firmware, which is basically the base layer that is installed on your network card. There is the bootloader, which is the first stage that actually starts the process of the operating system installation and provision. And then you have the actual installer that actually does the whole trick for you. Firmware, again, it depends on whatever hardware slash virtual hardware that you have. There is a BIOS. So first of all, it depends. You can support the firmware can support actually BIOS or it can support UEFI. In the UEFI world, there are also two choices. Some firmware support full iPXE, basically with the HTTP capabilities, and some firmwares do not support that, and they still rely on good old PXE, which means TFTP. So those are the transports that I have actually put here. Then you have the next stage, which is the bootloader. The bootloader for TFTP-based installation is Grub. And for iPXE, we do support iPXE UEFI, so we can chain code iPXE UEFI and iPXE script, basically that is complementing the thing. And the third stage is actually is always the same. No matter which bootloader you did use, you get your kernel and init RAM drive for the installation, basically. So that will be your initial kernel that in RHEL family it will run Anaconda scripts. For Debians, I'm not entirely familiar with their nomenclature, but there is the equivalent of it in the Debian space too. So what do we know about IPv6 in all this mess? So UEFI started supporting IPv6 from UEFI 2.3, which means BIOS is, although it's not officially supported, I have seen some references to BIOS supporting IPv6. I can't promise that it will work. What else? IPv6 is a completely different protocol, so they have all new messages and all new way of announcing the fact that there are Pixie capabilities on that network. So first of all, it's not related to DHCPv6, rather to router advertising messages that are sent, and those have to provide a special bit saying, it's a managed bit actually, saying that this network is managed by DHCPv6, hence the firmware needs to start the DHCPv6 solicit message, basically this start the querying for the Pixie information. And then there is the DHCPv6, which again, it's entirely different beast from my DHCPv4. They have a bit different way of doing things. The most important things for us in the Pixie case is that you have to supply the boot file URL option. It's option 59 in the DHCP protocol. If for IPv4 we have supplied two options, basically, we have supplied the boot file name and the next server. In DHCPv6, they are giving us only one option that is a URL. So it's a full URL. You can supply either tftp/something or HTTP or whatever. Again, you can supply that, but it depends on the firmware to read that property. So if your firmware doesn't support HTTP, it will just break or ignore it or do some weird stuff. So you have to make sure that the options that you select are actually supported. Also, currently we are not currently we don't have a managed DHCP-v6 solution in Foreman. So we had managed DHCP before. ISC DHCP was supported actually as managed. So Foreman was actually creating all the DHCP records and doing all of your DHCP work, which was great, but ISC is deprecating their DHCP server. They have built something called Kia to replace it. It has two layers. There is the free layer, and then there is commercial things that you have to pay money to actually get them. So we didn't have we didn't integrate with Kia currently. So it means that the DHCP server management has to be outside of Foreman. Sorry guys, more work for you. We don't have anything to do with that. Now about day 2. So facts. In IPv6 we have actually modified the way the facts are read from fact reporting, and we now allow the provisioning interface to be an IPv6 only. Before that, the provisioning interface had to have an IPv4 address. Now it can actually work with IPv6 only addresses, and it will work. Multiple IPs. Yes, in IPv6, each NIC basically is allowed to have multiple IPs, as opposed to IPv4, where a NIC was tied to a single IP. Foreman doesn't have the concept of multiple IPs for the same nick. We actually take the public one. So we discard the local link, and we mainly rely on the fact reporter to actually report the correct IP that will be used by Foreman. Most of fact reporters have a single IPv6 field, so we actually read that. At least that's what I have seen till now. So that could be a problem if it's not reported correctly. Just take a look that it works as you wish it to. We also consider IPv6 fields for DNS resolve queries. Internally, when we decide which interface can become the provisioning one, we actually check for IP resolve, like which IP address is actually resolving for the for Foreman hostname. And so if you have that correlation, it means that the interface can be selected as a provisioning interface. So now IPv6 field in the interface is actually also considered. So if before that we were trying only IPv4 addresses, now we actually try both IPv4 and IPv6 addresses. So this is actually from a host. For remote execution, there are two settings actually that were existing even before my effort that are relevant for IPv6. They actually work with IPv6 and have checked that. First of all, you have the connect by IP. So if your host doesn't have the proper DNS name, you can actually use IP for the communication. And the other property is prefer IPv6 over IPv4. It means that if an interface has both IPv6 and IPv4, which one would be selected? This property actually selects one or the other. Just a reminder, that works for remote execution. It's not a general Foreman setting, which means that internally, we do prefer IPv6 address, and it's not configurable. So there are places where I actually check for if IPv6 address exists, then use that. If it's not, if it doesn't exist, then I will use IPv4 and so on. So that's something that I wanted to mention. Now, areas where help is actually needed, the more interesting stuff. Dual stack. We didn't test it yet. So if you have dual stack environments, please test this stuff and see if there are any things that we are missing. Feedback is more than welcome around it. Compute resources. We didn't integrate. We didn't work on integration with compute resources, which means that if there are special fields that are reported as IPv6 in the compute resource, both ways, like setting up an IPv6 field or a compute resource that reports IPv6 fields to us, we didn't touch it. There, I have some notes that I have identified the places where we actually touch this area, but I didn't have not the time and not the ability to actually to work on it. So a lot of help is needed in this area. Otherwise, the option that we will have is actually deploying a machine as a bare metal. basically. So we will need to break the compute resource connection if it's something that is important in your specific case. And manage DHCP again, as I have said, we didn't integrate with Kia, with ISC Kia, so any help in manage DHCP would be much appreciated. I think it's quite necessary to have the all-around case for us. And that's all. Questions? Yeah, go ahead. The mic is here.
Yeah.
Want me to pass it?
Yeah, about the DHCP. I've seen that Red Hat in Red Hat 10, I think there's a new DHCP build. Is it there?
It's Kia.
Yeah. Oh, okay.
It's Kia.
Yeah, my question is more, so will Foreman stop support DHCP until a new one is found, I would think, or how is Foreman going to manage it?
So current support, we're not dropping current support, so you can do that. And for IPv4, it works.
Yeah.
It works great. But ISC, the company that actually developed the previous one, is actually not supporting IPv6 in the older one, and they have rewritten basically the older one, and they have created Kia. And Kia is their solution to IPv6 support. And that's one of the reasons I asked for help in managing DHCP, because basically we will need to see how to manage, properly manage DHCP with Kia.
If I may, so for those of you who don't know, the way it works with Smart Proxy basically has the API for managing DSP, and then there are multiple provider implementation. So I see DSPD, that's the one we default to, but we always have multiple ones. For example, we also have one for info blocks, and there's some others that I forgot the name of. But they basically tasked them to create also for ICKIA. The problem is the API, the Smart Proxy API, it never supported IPv6, it's hard-coded IPv4 only, and that's sort of a module that needs to be changed, developed. And one big reason, like ICDSPD, it did support IPv6, but there was no management API. So it was basically, you can just run it and then we can never touch it. So it was never really useful. I know Dimitri, about 6 years ago or something, he already started to look into this and never really got that far. A big problem used to be that IPv6, the way when you boot it, it's identified by device UID. And if you're in a netboot environment, you don't have that because it's not persistent, because you're supposed to store it on disk. But so they have extended DSPv6 now with actual MAC address, so there's more something to be conscious about. But that's only a few years old, so.
And it's kind of optional again.
Yes.
It depends on the firmware. If the firmware will report correctly everything, then it means that the DHCP server can actually read it and do something about it. But no one actually, like the base protocols do not require anything else from device UID, which is basically a virtual construct. So each machine can decide whatever it would be.
But it would be very useful if users here have networks to share what kind of service you use. What would you like to see? Like you said, RHEL 10 will use ICKIA, but there's a good chance that some IT departments already have some other choice, some other preference. So we, as you said, we look for feedback there. How do we meet your demands?
If you want the use
What
case,
are more pressing demands, I would say?
if you want the use case to, we're currently running a dual stack setup with IPv6 provisioning using Infoblox. We don't actually provision DHCPv6 in there. Instead, we have fixed DHCPv6 rules, which boot into IPv6. And IPv6 pulls a script which boots Foreman and provides both the MAC address as well as the BIOS UUID. And we have some other plugins to allow us to boot off of BIOS UUID from multi-interface machines and stuff like that. So we basically bypassed all of this to get it working by just telling IPv6 to boot, just give it the MAC address. Like they're working with any firmware.
Yeah, there's also an implementation with earlier where we just relied on HTTP boot and have fixed URL tell the app name basically is how you configure a server and work. So that's not a solution, but that's maybe an easy one, I believe.
So basically, the bootloader grab specifically, it uses MAC addresses, no matter if you're using IPv6 or IPv4 for the basic PXE communication. So basically, in order to get the grab EFI file or the grab BIOS file, you can get them both. As long as you are getting grab actually start running on your machine, it will look for grab config dash your MAC address basically. So that will, from that point on, basically in the process you can use MAC address. So the main problem is with DHCP and identifying your machine. That's why that's where device UID is actually important. So yeah, there is that.
But for the provisioning, itself, you don't necessarily need the UUID of a device that will be later on be used. You can have a dummy one, right?
As you don't need it, you don't need to specify it, but if you don't specify it before, it means you can only use the HCP basically, because Foreman was using static IPs by actually creating records in your DHCP server. It was a record MAC address to static IP. We can't do that because we don't know instead of MAC address, it should be a device UID. And if you don't have that.
Indeed, right, okay.
So yeah, that's the importance of device UIDs. So. Anything else? So yeah.
Thank you, Shimon.